Welcome back, dear students. In the previous videos we have found out the HCF and LCM of two numbers by prime factorization and Euclid's long division algorithm. I hope you would have understood them and practiced the questions. Then the next crucial topic that comes is proving a number as irrational. Right? This is a must in board examination. So first of all, before I start, we'll give you a brief overview about rational and irrational numbers. Now, what are rational numbers? Rational numbers are the numbers which are written in the form of p by q, where q should not be equal to 0. And irrational are the numbers which are written in the form of square roots or cube roots. You would have finalized in your junior classes. Right? Now, while proving a number as irrational number, we will use the method of contradiction. In this method of contradiction, we will assume that that particular number will be rational, and then we'll prove that our assumption was wrong and hence it has to be irrational. So this is kind of a template. Template is a thing where you don't deal with lines, they will remain same as the same they are, and you just have to vary one or two things here and there in the examination. So while attempting a question, you will start with this little bit of a linguistic part, that is, if possible, assume to the contrary that given number, let's say whatever the number over there is rational, provided A and B are co-prime. Now what are co-prime numbers? Whose HCF is 1. And if it is proved that A and B are not co-prime, then our assumption will be wrong and then we can say that this is 1. So before you start a question, now whatever the question appears in the examination hall, either it is root 3, root 5, root 7, root 13, root 11, so this statement will remain same. That says, if possible, assume to the contrary that whatever the given number is rational, provided A and B are co-prime numbers. Right? Then by the end of the question, we will prove that the given answer, that our assumption was wrong since they are not co-prime, and then we'll say that our assumption is wrong, that they are co-prime, and then we'll end it with this thing. So let's see if with an example that will be. Meanwhile, you can take a screenshot of this if you want to, or you can also find this in the books also. Okay. So now let's start. If we have to prove root 5 as irrational, what we are supposed to do in that particular case. Root 5 is irrational. Right. So again we'll start with the English part, that is, if possible, assume to the contrary that root 5 is rational provided A and B are co-prime numbers. Right? Again, co-prime whose HCF is 1. Now next step is you will equate it that root 5 is A by B. Now what you will do is you will put a square over there, squaring both sides. So the 5 is equal to A square by B square. So now you can write it out that B square will be A square by 5. What I have did, I just cross multiplied it. It was the numerator, it is denominator, I just shifted the values over there. Now with this, you can again write it as A square is divisible by 5. So A is also divisible by 5. Right? Or you can also use it in different form, that 5 is a factor of A square, and hence 5 should be a factor of A. Now whatever the terminologies you will use, you just have to make sure that you stick to one particular, either the divisible one or the factor one. Nevertheless, the values and the meaning will be the same at the end of the equation. Let's take it as equation 1. So what we have did, we just have written that given number as A by B Squaring both sides, whatever the number over there, the root will vanish out of from here, it will be a square by b square. Then you will cross multiply it, that b square is a square by 5, and you will write either a square is divisible by 5 and a is also divisible by 5, or you will write as 5 is a factor of a square, or 5 is also a factor of a, whatever the thing is. Right. Then in next step you will assume let a is equal to 5c. So the same number with any of the constants that you would like to take. You can take c, d, e, f, k, lambda, whatever you like, but it has to be some constant over there. So now we'll replace the values. B square is equal to 5c whole square by 5. So this becomes b square is 25c square by 5. This cancels out by this. So this becomes b square is equal to 5c square. Then again we will write b square divisible by 5 is c square. Now again you will see that initially it was a square that was being divided by 5. Here again b square is divided by 5. So then we'll use the same thing. Either we will write b square is divisible by 5. So b is also divisible by 5, or you can say 5 is a factor of b square and 5 is a factor of b, and take it as equation 2. Again, if you are using divisible in part 1, you must use divisible in part 2. If you are taking factors in part 1, then you must stick to the equation that is factors in part 2. Now let's see how this will go up. This is 1, this is 2. Now you would see that in both the cases a is also divisible by 5 and b is also divisible by 5. So co-prime means they could not have any common factors other than 1. But now they both are divisible by a common factor, that is 5. So hence we can write it over here that since, or you can say from 1 and 2, it is clear that both a and b have a common factor, that is 5. Hence they are not co-prime. Now since they are not co-prime, so we'll say that our assumption that root 5 is rational if they are co-prime was wrong. Hence they should be rational number. So our assumption that root 5 is rational provided a and b are co-prime is wrong. Hence root 5 is irrational. And hence root 5 is irrational. So this is how you are going to do it. Right? You can take a screenshot of this. We'll proceed with the second example where we will not be writing all these English terms. We will only be solving the middlemost of the question so that you can get a hint what is supposed to be done. Right? So I would recommend that you don't write it down because that will take a lot of time. You can directly take a screenshot and then we'll proceed further. Okay, I hope you have taken it. Now let's say if they have asked us to prove root 7 as irrational. So again we will start with this first step, that is a by b squaring with say 7 is equal to a square by b square. Then b square is a square by 7, and then you will write that 7 is a factor of a, and then we'll proceed that a as 7k. So b square is 49k square by 7. So b square is 7k square. B square by 7 is equal to k, and hence you will again write that 7 is a factor of b. 1, 2. I have skipped up the first terms, that is square and square, so I can directly conclude that it is a factor. So now you can say from 1 into it is clear that both a and b have a common factor that is 7, hence they are not co-prime. Right, and then you will proceed with that statement. Right, so this is all what you have to do while proving a number as irrational. It might look clumsy in the initial, but once you practice it 2 or 3 times, it will be very easy for you to understand it. Right, thank you.